Okay, so now studying for the final, we were talking about this question 5.4 in 5.4 problem number 20, dealing with exponential modeling. So I'm assuming that you have the book in front of you, that you can see the data set that's in 5.4 problem number 20. The problem states, let F of T be the revenue in millions of dollars from sales of blank audio cassettes in the year that is T years since 2000. A. Use a graphing calculator to determine if the data is better modeled with a linear or exponential model. So we're trying to decide between a linear model, which has a form y equals ax plus b. And when you see the data, usually falls in a straight line, versus exponential model, which is y equals a times b raised to the x. And in this case, if we're talking about exponential decline, it'll have the shape to it. Okay, so looking at the data. So I've already loaded the data into my stat edit. So now remember, T represents T years since 2000. So 0 is the year 2000, 1 is the year 2001, 2002, 2003, 2004. And then over here, 162, this is the $1 million sales from revenue from sales of cassettes. So this is 162 million, 129 million, 98 million, etc. All right, so we need to decide if this is better modeled with a linear or exponential model. So to do that, I'm just going to go ahead and plot it. So I'll go to second y equals, go into stat plot 1. So it's on, good. It's going to do a scatter plot, good. List 1, list 2, and the marker here in blue, okay, all's good. If I do zoom, and then I'm going to do zoom number 9, which you see here is zoom stat. So I'll go down. There we go, zoom stat. Now it looks like I have an equation there somehow. Let me go ahead and just turn that off. So I'll go y equals, nope, stop. Y equals, clear that equation. Okay. So does it seem to fall into a straight line or does it curve towards the end? So remember, here's the general shape. So a straight line or some type of curve. It looks more curvish. If you should ask me about it. I think this would be a good candidate for an exponential model. All right, so let's go with exponential. B then, find an equation of f. So remember, the generic form here is, so it would be f of t, because the input is time, a times b to the t. And then I'll let my calculator do the exponential regression and figure out what the a and the b are. So I'll go into stat, I'll go over to calc, and I'll scroll down to exponential regression. To list 1, list 2, yes, I would like to store my regression equation in vars, yvars, function, y1. Good, and I'll let it calculate. So my a is 160, about, so let's see, f of t equals 160, and then my base, b to the t, the calculator here, is 0.79. Go ahead and 0.79. All right, now if you recall, 160 is what we call the initial amount. So at time 0, it should be somewhere around 160. And if you look at the data set, our estimate is that the initial amount should be 160. It's from the data 162, so not bad, especially for exponential regression. And then this base right here, the 0.79, means that we get to retain 0.79 well, 0.79 or 79%, percent sign here, per year, which means that we're going to lose 21% per year. Okay, so that's what the individual parts mean in this context. All right, so there is our equation. So let me go ahead and just grab this real quick because we're going to be taking it with us. So copy. All right, so next question. Predict the revenue from sales of blank audio cassettes in 2014. Okay, so remember that T in this case is the number of years since 2000. So in this case, I want to use T14. So let me use my equation. Okay, 0.79, and I need to insert f of 14 equals 160, 0.79 to the 14th power. And then I'll let the calculator do the work. So 160. Do it. Here we go. 160 divided by times 0.79, close parenthesis, raised to the 14th power. So 5.9. So f of 14 is 5.9. Okay, so the input, let's see, is years, and 5.9 is revenue in millions of dollars. Okay, so in 2014, we expect the revenue to be at $5.9 million. Okay, so next question here. So predict when the revenue will be 1 million. Okay, so right here, when. Here, T is unknown. Okay, so f of t, what year? So I don't know what year. So what year will this equation equal 1 million, or the output in this case would be 1. Okay, so I need to solve for t. Now, hopefully at this point, you already have a game plan in your head about how you're going to tackle this problem and know that that game plan is somehow going to involve logarithms. So what I need to do is I need to get this base of 0.79 to the t isolated by itself. So to do that, I need to undo the operation that 160 is doing to it. 160 is multiplying. So to undo that, I need to divide. So I'm going to say 1 divided by 160. Let's see. So 1/160th as a decimal approximation is 0.00625. So let's see. 0.79 t equals 0.00625. All right. So now, let's see. Extend the page a little bit. All right. So now we're going to use a logarithm. So we're going to say natural log. And remember here, you can really use any log that you prefer, but natural log is easy to use, so I use it. So we're really saying the natural log of this quantity is equal to the natural log of that quantity. Two, 5. All right. And then by the power rule of logarithms, I get to pull down the t and make it a product of exponents here. So 0.79 equals ln of 0.00625. So then t equals, and then I'll divide by the natural log of 0.79, so I get this ratio here. Okay, and then I'll let my calculator figure out what that number is. So I'm going to say the natural log is right here, so natural log 0.00625 divided by the natural log, what's the number again? 0.79. 0.79. All right, so 21 is the value. So t equals 21. And what does that mean? 21 years since 2000. So we'd say the revenue will fall to $1 million in 2021. Good. So that will probably do it for the question. There is one more question on there dealing with half-life, although we're not going to deal with half-life in the exam, so we'll just stop right there. That is basically what you would need to be able to do on the final. You need to know how to find the exponential equation using exponential regression. We did that. You need to know how to interpret the parts. What does 160 mean? What does 0.79 mean? And then be able to use it. So make a prediction in the future or figure out at what time does a certain output occur. So if you understand that, you'll be cruising for the final.